Hey everyone, welcome back to Just a Metric podcast. I'm Suraj, and today we've got with us Vladimir Siankov, the founder and chief technology officer of zk-Fold. zk-Fold is an innovative project that specializes in zero-knowledge smart contracts and zk-rollups specifically designed for Cardano. So Vladimir, super excited to have you on the show.
Yeah, hi Suraj. Thanks for inviting me to be.
So maybe you can give a brief introduction about how you start building now zk-Fold.
Yeah, so I started in the blockchain industry like 2 years ago. So my first project is Endcoins, which is a private transaction solution for Cardano. And about half a year ago, we started zk-Fold. So what we are building is, so zk is our final product actually, but what we are building now is a language for zero-knowledge smart contract, and it is called zk-Fold Symbolic. It's like a Haskell DSL similar to Plutus TX that allows you to write zero-knowledge smart contract.
Before we get into the details of all the things you're building, maybe we can just zoom out a bit and look at the high-level concept of why are you focusing on zk-rollups on Cardano? Because different blockchains have different scaling roadmaps, and Ethereum has this rollup-centric scalability approach with optimistic rollups and zk-rollups, and zk-rollups being touted as the long-term method. On the contrary, Cardano has a bit different approach, focusing on multiple fronts, focusing on side chains, Hydra, dApp accelerator concept, along with layer one scalability map based on input assets. And you are focusing on zk-rollup. Where does zk-rollup fit in this scalability roadmap, and why are you taking this path?
Yeah, so I think these other technologies that you mentioned, they are not mutually exclusive, so they all add up to greater scalability. If we consider Hydra is a solution, but it has a limited use to specific applications which can be run in state channels. For example, games, microtransactions, all this kind of stuff. It's basically microtransactions when you need to coordinate the efforts of different parties. For example, like to coordinate the work of butchers, some decentralized application. Hydra could be used for this reason as well. Then input endorsers, as you said, it is a layer one scalability solution and increases throughput quite dramatically. I mean, at least in theory, it can be used with zero knowledge stuff together for even greater scalability. So we saw that there is no concrete plan for zk scalability on Cardano, and we see this opportunity. So to improve Cardano and to build our company.
Why do you think zk-rollup is the right fit for Cardano as a scalability solution, or where does this zk-rollup fit in? I understand that it's a general purpose scaling solution. That means you can run different applications on top of it. But why I ask is that usually rollup centric roadmap also comes with a data availability layer from a layer one perspective. So if you look at Ethereum, they're focusing on the data availability layer. If you look at Tezos with a similar rollup centric roadmap, they are also building their data availability layer. And projects like Celestia, that's exactly what it provides. But if you look at Cardano, there is nothing in roadmap that says, okay, we are building a data availability solution. So that's why I asked, like, how does zk-rollup fit into this roadmap of Cardano, especially when the layer one is not building infrastructure to accommodate such solutions?
Okay, I got you. So first of all, Cardano is maybe unique in that way that you can have a big impact even without like separate data availability layer. So because of how Cardano smart contract transactions are constructed, basically in the rollup solutions, well, there are two bottlenecks in general in blockchain. It's compute and data storage. And zk technology contributes to solution of both, but first of all, it contributes to reducing the compute that you do on chain. And in this regard, you probably know that on Cardano, there are very hard limits on how much compute you can do in a single transaction. And K stuff, you can basically have unlimited computation on layer one on Cardano. Just you do the computation off chain, you prove the results of those computation, and you verify it on chain with zk-SNARK. And because Cardano uses a XO model, you can do a lot of stuff in a single transaction. And on Ethereum, it's like you can verify any computation, but at the end of the day, you are paying gas fees for like actions, like transfer tokens, these contracts, etc. On Cardano, it's like the smart contract logic. You compose actions off chain, and then you verify that your transaction satisfies the specification. That's what you do, and you can have a huge cost reduction in this.
Okay, so and what about the data part, like data storage part? Cardano is a blockchain that goes on to the opposite side of data availability, like tries to minimize the data. I mean, there are certain reasons for that, but on the data part, even if you are like have an advantage on the computation part, on the data part you have a disadvantage. So could you comment on that?
Yeah, so on Ethereum, I would say that it's not that there is more availability. It's probably that the fact that it is just cheaper. And I mean, I have looked it up. It seems like at some point they made it posting data on Ethereum cheaper, specifically to make this rollup solution like better and like more profitable. So initially the cost of posting data was higher from what I read, and the advantages that layer 2 solutions give you were not so great. But now if you compare the prices on Optimism or Arbitrum in comparison to Ethereum mainnet, then it's a huge difference. And yeah, so by introducing a separate data availability, we can get I believe we can get the same kind of results in terms of cost reductions for Cardano. Yeah, posting on mainnet is in fact quite limited, but we can use a separate.
Yeah, got it. There's this technical difference between what is a validium, what is a zk-rollup, and the trade-off with is that you have your own data availability set up for the rollup. That means so you are basically building a validium for the short term. How does the data availability work in your case? Are you using a data availability committee or similar thing?
Yeah, so this hasn't been decided yet. One way to do it would be to use existing solutions such as Celestia.
Okay. Oh, so I have seen this concept of a new rollup coming on Ethereum. It is called Eclipse. So Eclipse was using SVM, Solana Virtual Machine, and settling on Ethereum Layer 1 and data availability on Celestia. So that's like, oh, people are discovering new ways to build these things. And so you are still deciding on the data availability part.
Yeah, because we have two products before that. So we have time to decide the data availability. And then at some point we plan to transition to a full zk-rollup. So we will have a sidechain, data sidechain, where we store data.
Data sidechain, like sidechain is this front on Cardano, probably getting more developed post midnight launch. So people have this traditional concept of sidechain, and I don't know how exactly Cardano sidechains would be different, but it seems like this is a front that we would discover as this technology further develops over the course of the coming months or years. So coming back to the zk-rollup that you're building, I looked through the proposal, and it's like it has three different components: a zk-Wrapper, fold, rollup, and a data sidechain that you just talked about. And you said you are using a SNARK-based solution. So could you just walk us through the architecture of the zk-rollup you're building?
Yeah, sure. So what we are going to do is we plan to start with the developer tools, and with layer 1 scaling. So what we are building right now is a language for zero-knowledge smart contracts. And then this is the first product. The second product will be the zk-Wrapper, which is basically gives you the same functionality, but extended to other on-chain languages, because we imagine that some people will be hesitating to learn a new language specifically for zero-knowledge smart contracts. So they might want to use, and we plan to support those languages as well in the zk-Fold wrapper solution. So the language that we are planning to do it is a high-level language, and you as a developer, you don't need to know anything about arithmetic circuits or zk-SNARKs or anything like this. So it's as high language as any other on-chain languages. And then when we are done with this, when we use this kind of technology to the maximum that it can provide on layer 1, then we will go to layer 2 and build Validium rollup and then zk.
Okay.
That's the plan.
Okay. Yeah. So could you explain what a zk-Wrapper is?
Yeah, so as I said, it is just an addition to our zero-knowledge smart contract language, which allows you to build in any other on-chain language.
Okay, so it is more like a platform where, regardless
Yeah.
of which language you know, you can code on it. So there is no bottleneck for developer adoption in that sense.
Yeah, we want zk smart contracts to be as accessible as they could.
So why did you go for zk-SNARKs instead of zk-STARKs?
So the zk-STARKs have the advantage that they are quantum resistant, and I mean that if we compare like specific, then they could be also faster, but at the same time they have larger proofs, and this makes it inaccessible as like on layer 1 on Cardano. On Cardano, what will be available soon is BLS Perf elliptic, and it is used in several zk-SNARKs protocols, specifically in Gross 16 and in Blonde. And so we are kind of limited by this choice, but at the same time you can do recursive proofs, so you can have like on the outer layer you could have like vanilla zk-SNARK, and then you can use basically any protocol you want as a like an inner proof.
Okay, got it. So Plonk is a zk-SNARK, and the one trade-offs with the current zk technology is that you need a trusted setup to to create the proving, what do you call it? Like, you need a trusted setup to create the proving parameters, verification parameters. And a trusted setup ceremony has the trade-off that it's a one-time process. You need a handful of participants participate in that trusted setup, and there's something called as a toxic waste that is generated from the data. That means if that data isn't destroyed, the parameters that generated through the trusted setup ceremony is can be compromised later. And if you need to upgrade that parameters again, you need once again this trusted setup ceremony. So how do you see such trade-offs because zk tech is still a very fast developing field, but it also comes with trade-offs like this. So what do you think about such trade-offs?
Yeah, so first of all, there are like two types of these trusted setups. You have a universal trusted setup and circuit-specific trusted setup. And the advantage of using a universal trusted setup is that basically you use one single setup that can work for any circuit. And in particular, these kind of ceremonies have been performed in the past. And we haven't decided this yet, but one way would be to use just like the parameters from this one of the ceremonies that have been already concluded, and I mean people trust them, and so we can just reuse one of those. An alternative is to do our own ceremony and then use the parameters that we obtain this way. In circuit-specific trusted setup, you do not have such luxury. You have to create your arithmetic circuit, then you do the trusted setup ceremony for this specific circuit. So it's like for each new project you need to redo this kind of ceremony. In Plonk we have universal trusted setup, so both options are available to us.
That you can decide depending upon the situation. Okay.
Yeah.
So what kind of throughput would it add, like would it enable on that particular platform? Or is it like multiple zk-rollup solutions, or is just one high throughput solution?
So I think nobody knows like the limit of how much you can do with this technology. It's like you can see like in marketing materials for other zk-rollups, they say like, I don't know, 100x, 1000x the throughput. I think it's difficult to say like what is the limit for this, but and it's also it will be limited by the sidechain, what kind of throughput you allow on the data sidechain, because you can do you can make it very very cheap for people to post on the data sidechain, but then it will grow very fast, and you will have data problem when it's like your data sidechain is many times larger than like in terabytes of data. then it becomes, even if your original design was decentralized, fully decentralized, and at some point it could become pretty centralized. So you need to limit yourself. I think at the end of the day, you need to limit how much scalability you have to provide in order to ensure that your system is still decentralized. So there is no hard limit on the throughput, but you have to balance it with decentralization.
Okay, so I have seen that there was a zk-Fold proposal in Project Catalyst, and it was not funded this time through Project Catalyst. So how is the development going right now, and what kind of are you looking for new partnerships, new investment? How are you pushing the project forward?
Yeah, so since then we announced that we have joined two accelerate. One is called Trust Valley, and it's based in Switzerland, and another one is Genius X, which is an online also from Switzerland. And we are trying to get right now we are trying to get investments from private investors and VCs and angel investors maybe. In the meantime, like part of the team is continuing working on the project. We are discussing it all the time, like the what is the best technical choices for this and that. And I mean, like a part of the team is continuing to develop the zero knowledge smart contract language right now.
And one more question I wanted to ask you is about this composability with other parts of other scalability solutions. Or if you deploy a dApp on a zk-rollup, and composability is a big topic when it comes to how DeFi works, and how different, like each smart contract is a Lego block, and how you can combine it and use it is basically the concept of composability. And when you're building layer 2 solutions, the composability part of the layer 1, is it a bit destroyed, or how do you think this would work, especially from that aspect?
Yeah, it's a great question. I think Cardano has an advantage in this regard of the UTXO model. On Ethereum, it's basically the composability is destroyed a little bit with layer 2 because your liquidity gets split between layers and you cannot use it essentially in the same transaction. But on Cardano, your transactions can be very complex, and in particular you could use many scripts, for example, in the same transaction, and many inputs and outputs. And the way we plan to do it is we plan to one single script, verification script, that checks your zero knowledge proofs. And this way our layer 1 smart contracts, and as well as the eventual zk-rollup, will use this single script, and they will be very much composable with each other. So you could imagine, for example, DEX that is both on layer 1 and layer 2, and you can access its liquidity on both layers in one single transaction if it uses our smart contract.
That sounds very exciting, because this is a very big topic even in the Ethereum space, and if you already have some solutions for what you're building, that is fantastic, and can't wait to see it in real life. So you said at the beginning of the conversation that you have some announcement coming in tomorrow. Of course, the video will come after that once you have announced it. But what is that announcement that you talked about in the beginning of the video?
So what we are announcing is that our first product is zero knowledge smart contract language. It is called zk-Fold Symbolic, and as I said, it is a subset of Haskell, similar to Plutus TX, and it allows you to build arithmetic circuits in basically a very high level language, functional programming language. And this way, I think it will reduce the barrier to entry for developers who want to create very efficient and complex smart contracts. Because I mean, on Cardano, I think one of the main limits is the limit of execution units, so memory, and it limits what kind of transactions you can make. And so I think in this regard, zero knowledge smart contracts will open open potentially new use cases on Cardano layer 1. And yeah, I mean, we have plans to showcase the power of these smart contracts very soon. And as well, another thing that I want to mention is that we will have a demo of this language during the coming Cardano summit. So the demo is basically ready, and we will release it in a week, so people can try out for themselves and test how it will not be like a fully fledged version of the language, but it gives you an idea of how you can make smart contracts in this language.
So using this zkFold symbolic language, you can create smart contracts on Cardano layer 1 to build applications, which is much more computationally efficient than what we have right now. You don't even have to depend upon a layer 2 or whatever. You can work on layer 1 much more efficient using this language. Oh, that sounds fantastic, because that itself would be adding a lot of efficiency that Cardano very much needs right now. And that is a fantastic announcement. And this is an obvious question for a lot of people. So when you deploy a zk-rollup, would it use ADA for transaction, within the, or a separate token?
We haven't decided on the token just yet. I mean, I don't know, to be honest. It haven't been decided yet. We don't plan to release a token anytime soon, this I can say. We have different business models for now.
Okay. Yeah, I think everything in crypto has a token, and I don't think it's at least from a very non-technical perspective, I don't know how this is going to work long term with all these tokens, but because people need another business model for this to be financially viable. And so looking forward to the things that you're releasing, and looking forward to see how zkFold evolves in the coming months.
I mean, I just want to encourage everybody to check out the demo. Yeah, and you can always reach me out or write to us. info.fold. We are happy to talk and to answer your question.
I'll add details to your website as well as Twitter handles to the video, and hopefully people with some great ideas can reach out to you and share those ideas. Okay, Vladimir, that was a fantastic talk with you, and I hope to have you again in the show. Okay, so thank you for being here, Vladimir. Thank you so much.
Thanks for inviting me. Bye.
Bye.